Alright, what's up guys? I am going to make a quick video about assignment 6.4 just so that you guys exactly know my expectations for this assignment and so you guys have a guide as to how to do these questions if you have how to do these problems if you have any questions about how to do them. So I got a lot of questions from you guys yesterday, so I'm going to try to answer them in this video. Now, looking at this first question, we're being asked to find the inverse, but we have a graph, so we're going to need to graph it. And what we're going to do is we're going to make a table of values like we did in the notes. So first we're just going to find the normal function values from this one right here. And then we're going to switch the x's and the y's so that we could have our inverse values, our coordinate points for the inverse function. So getting all these points, we end up with -4, -4, -3, and -1. So we got these two so far. Then we have 0, 1, and then finally this one all the way over here at 5 and then 3. So what we're going to do here is our x's are going to become our y's, and our y's are going to become our x's. So looking at this first point, we're going to switch both of them, which you might not see what it does because they're the same number. But for example, this next point, -3 and -1, then now becomes -1 and -3. 0, 1 is going to become 1, 0. Finally, 5, 3 is 3, 5. And you could plot it on this graph on the right, but I think it actually is more clear if you plot it on the one on the left. So -4, -4, we have an overlapping point right here. -1, -3 is going to be right here. 1, 0, and then finally 3, 5. So connecting all of these points, we get shapes like this. And if we just compare these functions together, we have some intuition as to whether or not they're inverses. They look like they're inverses. But the second part of this question is to make sure you graph it with this y equals x line. And if we were to fold this coordinate grid across that y equals x line, I'll label it right here, y equals x, we'll see that the graphs perfectly overlap. So we know that we found the inverse for sure. As for these problems, they are really not too bad. I'm going to solve one completely, and then I will set up one more just so that you guys understand how to solve these problems. So I'm going to solve number 3. So g of x is equal to -3 plus radical x plus 2. So the first thing we're going to do is we're going to switch this g of x for y. And that is just so that we could do the algebra a bit easier. You guys probably benefit from having some structure, some repeatability with these types of processes to solve questions. But anyways, now once we have y in our equation, we are going to swap the y and the x positions. Same way that we did on the table, we're just doing this algebraically. Once we do that, we enter the inverse world. And I try to denote that by writing it in purple. And now that we're like this, we are just trying to find y equals. We need to get y by itself. So we got this whole thing, and we also got this -3 on this one side. So we'll benefit from getting that -3 away from here. The way that we do that is adding 3 to both sides. If we add 3 to the right side, that cancels out. If we add 3 to the left side, we end up with x plus 3 is equal to square root y plus 2. Now that we got all this, we have this square root y plus 2. But we don't want square root y plus 2, we just want y. So the way to cancel that out is to square that whole side. And then that inverse operation takes place and that cancels out. But same way that we add plus 3 to both sides like we did in the previous step, we have to square both sides. So once we do that, we're going to go up here and we're just going to leave that part like that. X plus 3 squared is equal to, well, the square root canceled out, so all we're left with is y plus 2. And you can feel free and expand this term out, FOIL it out like how we did in one of the previous units. But if you notice, it's almost looking like vertex form, if you guys remember how that looks. So we can just leave it like that. The final step would be to subtract 2 on both sides. Cancels out right here. So we're going to end up with an equation with x plus 3 squared minus 2. We could even say that this equation got shifted 3 to the left and 2 down. That's why it helps to not expand it out all the time, but that's just an extension. Point is, we got our inverse function right here in the purple box. So the next one I'm going to do, so that you guys understand, is number 6. I'm not going to solve it all the way through, but hopefully you guys get some semblance of how to do it. So g of x is equal to 3 times x plus 1 squared minus 5. So the first thing we're going to do is replace that g of x part as just y. Now that we have this, we want to make sure that we can swap out these two terms. Sorry about that, that's my wife. Okay, so we're just trying to make sure that we could swap out these two terms like how we did in the previous example. So we got x is equal to 3y plus 1 squared minus 5. We're just switching the positions of them. And from this point, it's going to be pretty simple to repeat the steps. We have that minus 5 in the back and right here, which we want to get rid of. So we're probably going to have to add 5 to both sides. Okay, that's going to cancel out. At some point, maybe divide by 3. And then after we do that, we're going to want to square root both sides right here to cancel out with that y plus 1 squared. And then just doing this algebra as best as you can. Try not to make things as too complicated for yourself by expanding and foiling. But feel free to do it if you feel more comfortable with working with binomials and terms that way. But that's pretty much it so far for this assignment. It's basic algebra, and I feel like we've touched on this topic a lot in Unit 1 and even last unit, just working algebraically. But if you guys still have questions, just let me know. If you see me in the halls, I'll be